All right, so welcome back. We are going to finish up chapter 6 tonight in this video, and then I will post the videos that I need for the beginning of chapter 7 tomorrow. The reason why I'm splitting it up and only doing one more section in chapter 6 is because I want you guys to familiarize yourself with the exponent rules again. Remember way back when I talked about how those rules, you need to know them like you need to be able to write your own name, and it's because they were going to come back, and they come back again with a vengeance in chapter 7, because in chapter 7 you start to take those exponent rules, which dealt specifically with integers, positive and negative whole numbers, and says, well, now we're going to make them rational, which means your exponents are going to be fractions, and there's going to be some more rules that we're going to have to discuss, how to simplify them, and how to solve equations involving rational exponents and things like that. So we'll cross that bridge tomorrow once you familiarize yourself with the exponent rules again. Okay, so let's get started with chapter 6.4, which is equations with rational expressions and graphs. Okay. All right, so a rational equation is an equation that contains at least one rational expression with a variable in the denominator. So one of the things that I want to remind you of is something that we talked about in our very first class together. Excuse me. In our very first class, we started solving regular equations, right? That was chapter 1. And when we were solving those regular equations, I said to you, this skill of being able to take this, let's say 1/2 x plus 1/3 equals 5/6, something like that. The idea behind getting rid of all of these denominators to be able to solve this equation with the path of least resistance is absolutely critical in this chapter. Some of you were able to solve these equations by converting them to decimals and things like that, and that was all well and good, but you need to be able to say, all right, well, what is the LCD between the three denominators that we have? And you know that the LCD is 6. So what we do is we multiply every single piece to this by 6 to clear out all of these denominators. So we know that 6 divided by 2 is going to be 3, and then the x is coming along for the ride. 6 divided by 3 is 2, so plus 2, and then 6 divided by 6 is just going to be 5. And then when you solve this equation, you end up with a pretty nice answer of x equals 1. So the idea behind multiplying by the LCD is going to be absolutely 100% critical to being able to do these rational equations where there's a variable in the denominator. So these are all numerical in nature, 2, 3, 6. We are going to have algebraic expressions in the denominator, and we're going to first have to find the LCD, and then we're going to multiply by that LCD to get rid of all of the denominators that we have, and then we'll solve the resulting equation. So once we do that process of multiplying by the LCD, it takes us right back to what we did in chapter 1, which was solving for x, solving an equation. All right, so the domain of the variable in the rational equation is the intersection of the domains in the rational expressions in the equation, which means at the beginning of this chapter, if you recall, we focused on functions that were f of x is equal to 3 over x squared plus 5x plus 6. And what I said to you was we needed to figure out what the domain of this function was. Matter of fact, I posted a video of this last week, right? We had to set this denominator to not be 0. Because remember, if your denominator is 0, then that's going to cause the rational expression to be undefined. So we have to figure out what items cannot be in the domain, which is going to be a critical thing for us because it could lead to a false solution, but we'll get to that a little bit later on, okay? So you're going to want to make sure that you figure out what elements are not in the domain before you get started, because once you get a solution, you're going to be so proud of yourself. You're like, oh, look, I got it. But it may be a false solution. So I'll explain a little bit more about that when we get to it. All right. So first it says, let's give the domain of the variable in each equation. So the domain here, again, the x values. So what we want to do is we want to figure out what are the x values that are going to force the denominators to be 0. And most of you guys can see that when x is equal to 0, that's going to make this rational expression undefined. And when x is equal to 0 over here, that's going to make this rational expression undefined as well. So the domain of this equation is going to be x such that x cannot be equal to 0. So it's all other values that are in the domain. Doesn't mean that everything is going to be an answer to this equation. It just means that this guy is absolutely 100% not the answer to this equation, okay? Because it's not in the domain. So what I'm going to do now is I'm actually going to solve this, even though it doesn't say solve the equation. I'm just going to show you what we need to do because it's a pretty basic equation. So we're going to go ahead and solve this. So just like last time, last video, we looked at all of these denominators and we tried to figure out what the LCD was. So we're going to do the same thing here. So we have x, we have 4, and we have 4x. And the factors of x are just x. The factors of 4 are 2 and 2, but we could just write 4 if we wanted to. And then we can see pretty clearly here that this is 4 times x, which is the product of the first two denominators. So our LCD, based off of what we talked about last week, is going to be 4x. So in order to solve this equation, what I'm going to do is I'm going to multiply every single piece to this equation by my LCD. So I'm going to go off to the side and do my side work. So I'm going to take this 3 over x and I'm going to multiply it by 4x. And you can see immediately that the x's are going to cancel out and you're left with 12. So this first fraction turns into just 12. And then I'm going to go ahead and take the second fraction, which is 1/4, and I'm going to multiply that by 4x, and this time just the 4's cancel, and that leaves you with 1 times x, which is just x. So plus comes along for the ride, and then this 1/4 is just an x now. And then last but not least, we have this 9 over 4x, and if I multiply it by 4x, the 4's cancel, and the x's cancel, which leaves you with just 9. So as I promised you earlier, I said to you, once we get through this process of multiplying by the LCD to clear out all of the denominators, you end up with a pretty garden variety equation here. Now, they're not all this basic, they're not all this easy, but this is a pretty straightforward equation to solve. I just have to solve for x by subtracting 12 to both sides. And we get x is equal to -3. And that is okay because, again, the domain says x such that x is not equal to 0. So 0 was the only value that was not in the domain. This is a valid solution, and we can jump into the happy dance at that point, okay? So the process that we learned last week of figuring out the LCD, that was a pretty critical one. As you can see here, we found what that LCD is. And then this time, instead of trying to create the 4x down here, we're actually trying to get rid of all of the denominators that are here. And you can only do that when you have an equation, right? If you have an equation, it's fair game. Remember, I talked about it the very first class, how much I loved equations. You guys probably laughed at me, but equations are great because you can do whatever you want to them, including multiplying everything by this crazy 4x that we found over here. All right, and it was beautiful because it gave us this 12 plus x equals 9, which is a much nicer equation than what we started with. Okay. All right, so again, let's go ahead and give the domain of the variable in each equation. So again, factoring is critical here. If you have practiced your difference of squares, you've recognized that this is the product of both of these guys. Again, factor your difference of squares as soon as possible. So that's going to give you x is equal to -3, -2, and x is equal to positive 2. Those are the two values that are not in the domain. So x such that x cannot be equal to -2 or positive 2. Because if you substitute -2 in here, you get a 0 in the denominator. If you substitute 2 in here, you get a 0 in the denominator. And the same thing is going to happen here. If you square 2, you get 4. 4 minus 4 is 0. You get 0 in the denominator. So these are the no-go list. If we get an answer of -2 or positive 2, we are going to have a false solution. And again, I promise I'll talk to you about that a little bit later on. Okay. So again, we're going to actually solve this equation just because it's here, and it's good practice for us to do that. So we are going to solve this equation. In order to do that, we need to figure out what the LCD is. So x plus 2, x minus 2, and x squared minus 4. If you factor this, you just get x plus 2, nothing crazy. This was just going to be x minus 2, again, nothing wild. And there's my difference of squares, which is just x plus 2, x minus 2. So this is my LCD, all right? So my LCD, again, is the product of all the different factors raised to the highest exponent, which is just to the first power to the first power. So my LCD is going to be x plus 2, x minus 2, okay? And once again, let's bang out some side work. So side work says I'm going to take this first fraction, this 2 over x squared minus 4, and I'm going to multiply it by my LCD, x plus 2, x minus 2. And we know that this x squared minus 4 is really just exactly what our LCD is. So these are going to cancel completely, and that leaves you with just a 2. So the first fraction here just turns into a nice 2. We'll move on to the next one, 1 over x plus 2. When you multiply it by the LCD of x plus 2, x minus 2, the x plus 2's cancel, and it leaves you with 1 times x minus 2, which is, of course, just x minus 2. So plus comes along for the ride here, so it just comes down. And then this becomes x minus 2. And then the equal comes along. And we have one more thing to do, which is 1 over x minus 2 multiplied by the LCD, which is x plus 2, x minus 2. And this time the x minus 2's cancel, and it leaves you with x plus 2. All right, so x plus 2. Perfect. So now that we have everything that we need here, we can start to solve this equation if we wanted to. Again, you have variables in a couple of different spots. This x is here, this x is here. So we might want to move this x to this side of the equation. And you can see immediately that there's a big problem, that this is going to end up being -2 is equal to 0. And if you remember from chapter 1, there were 3 different styles of equations. We had our conditional equation, which led to one answer. We had our contradiction, which led to the variable disappearing, and we have a false statement here. Obviously, -2 is not equal to 0. So this is a contradiction. So the same thing is happening in chapter 6 that happened in chapter 1, where poof, we were solving our equation and variables disappeared, and we were left with this bogus statement of -2 is equal to 0, which is clearly false. That's going to be a contradiction. And then if you remember also in chapter 1, we had the identity. So the identity would be if you had -2 is equal to -2. So again, your variables disappear, and you're left with a true statement. 0 is equal to 0, 17 is equal to 17. You're left with some true statement. That would be the identity, which leads to all real numbers. Now, all real numbers except for these two. Remember, these guys are not in the domain, so they will never be part of a solution set because they're forcing these rational expressions to be undefined. So if we ended up with an identity situation where we had all real numbers as the solution, it would be all real numbers except for these guys. Remember, these are never a solution, all right, because they're not in the domain. All right, so hopefully I went slow enough for these first couple of problems in example 1, so you get the gist of what we're going to be doing in section 6.4. All right, so it says to solve rational equations, we multiply all terms in the equation by the LCD, which is what we've been doing, and then we can do this only with equations, not expressions. Yeah, so that just goes back to what I showed you earlier, and why I circled this equal sign over here, why I told you how much I love equations, because we got rid of those fractions pretty quickly because we had an equation. Remember, you cannot do this with expressions. You either add, subtract, multiply, divide. You simplify expressions, you can solve equations, okay? So determine the domain of the variable, multiply each side by the LCD, so you can see that they're pretty much following the steps that I do. Step 3, solve the resulting equation. And then step 4 is check, and I very rarely do this, just because I'm pretty confident in what I'm doing. If I wasn't, then I probably shouldn't be doing what I'm doing. All right, so let's go ahead and take a look at this guy. All right, so first things first, we want to figure out what is in the domain. So x such that x cannot be equal to something. So I have a 20 down here. That's not going to bother me too much. It's this x and this x that are going to bother me. We know that if x is equal to 0 and x is equal to 0 here, that's what's forcing these to be undefined. So x 100% cannot be equal to 0. Because remember, if this guy is equal to 0, if this guy is equal to 0, that's forcing these to be undefined. You can't have 0 in the denominator. Okay. Next step, let's figure out what the LCD is. All right, so we'll take 20, we'll take x, and we'll take 4x. And now this isn't like 100% solid, but I'm going to do it anyway. So 20, you can factor that to be 4 times 5. Now, I know some of you guys who are out there, you're like, yeah, but can't you break 4 down? Yes, you absolutely can break 4 down. But the reason why I'm not breaking 4 down anymore is because I see this 4 over here. So since my mama didn't raise no fool, I'm going to leave this 4 right here because that's going to be part of my LCD. All right. X is here, so x is just x, and then 4 and x, 4 times x. So remember, LCD is the product of all the different factors raised to the highest exponent. So what do we have for different factors? We have a 4, we have a 5, we have an x, and this 4 is the same as that 4, so we're not going to double count it. And this x is the same as that x. Remember, it's the product of the different factors raised to the highest exponent. So we do not need to include this 4 and this x again. So our LCD is just going to be 20x. So that is what we're going to multiply by. So I'm going to take this negative 3 over 20, and I'm going to multiply it by 20x. And you can see the 20s will cancel, and that leaves you with negative 3x. So our first fraction turns into negative 3x. Repeat the process for the rest of these. So 2 over x, if you multiply it by 20x, the x's cancel, and that leaves you with 40. So plus 40. And then last but not least, we have 5 over 4x. When you multiply that by 20x, the x's definitely cancel. Sorry, I missed. And then when you have 20 divided by 4, you have 5, right? So 20 divided by 4, they don't just completely cancel. A factor of 4 cancels, which leaves you with a 5 over here. And then, of course, you have 5 times 5, which is going to be 25. So this is going to be equal to 25. And again, remember how I got the 25 was it's this 5 that was existing, the new 5 that was the simplified version of the 20 when it canceled with this 4. 5 times 5 is, of course, 25. And then from here, look, this is chapter 1. This equation that we were able to create here is straight up chapter 1. So when we subtract 40 to both sides, you get negative 3x equals to negative 15. X is equal to 5. And it says to check your answer, but really what I do is I check this answer with respect to what is in the domain. As long as this number is not on this list over here, I'm going to be pretty confident that I did everything that I was supposed to do. X equals 5 is the solution to this equation. Okay. So of course, if you have questions on this, I will set up a session again on Friday. I will send out the email invitation tomorrow for you, so that way you can access that Q&A. And I haven't heard too many emails, or I haven't seen too many emails from you guys regarding, private tutoring sessions or anything like that. So I'm assuming that things are going pretty well for you. There were a couple of issues with the test with some answers. If you have those issues that pop up of things that you are confident that you got right, but the formatting was incorrect, I am able to go in there and like override the incorrect response. So if the math is right and the answers are correct, and how you inputted the answer is incorrect, I can go ahead and fix that for you. You just have to let me know. All right, so you will have to be diligent. I'm not going to check every single student, every single answer. So if you see that Math Lab has wronged you in any way, just let me know. And also, they allegedly have fixed their issues. For those of you who are having some issues with like accessing the homework and accessing the quizzes, or the tests, sorry, they upgraded their servers to make sure that they can handle the excess traffic that they're receiving due to everybody being online. And obviously, with upgrading those servers, a couple of hiccups happened, but they've assured us that no further issues should be happening going forward. So hopefully they fix that problem. All right. Okie dokie. So this is the same problem. So let's keep going. All right. So let's take a look at this guy over here. So once again, this is usual suspect. I see another difference of 2 squares right there. And I'm very happy because these are the factors of this difference of 2 squares. So again, first things first, I'm going to go ahead and say x such that x cannot be equal to what values? So x cannot be equal to -1, right? Because if -1 plus 1 is 0, so x cannot be equal to -1, and x cannot be equal to +1 either, because 1 minus 1 is 0. So these are the 2 values that are not in the domain. We want to make sure that we do that first, just in case anything funky happens a little bit later on. So again, we want to figure out what the LCD is. So LCD is x plus 1, and when we factor that, we get x plus 1. We have x minus 1. When we factor that, we get x minus 1. When we have x squared minus 1, when we factor that, we get x plus 1, x minus 1, which again is exactly what this is right here, the product of those 2. So that's a beautiful thing for us. So the LCD is x plus 1, x minus 1. And we repeat the process. Let's go ahead and do it again. So we've got our first fraction, which is 3 over x plus 1. When we multiply by our LCD, which is x plus 1, x minus 1, the x plus 1s cancel. And now we distribute this 3 into both of these, which is going to give us 3x minus 3. So this first fraction becomes 3x minus 3, right? Don't forget to distribute. That's an error that I see from a lot of students. Let's move on to the next one. So 1 over x minus 1. When we multiply by the LCD, x plus 1, x minus 1. Your x minus 1s cancel this time. And if you distribute 1, nothing happens. Interesting. So x plus 1 is our suspect there. So x plus 1 is what this second fraction becomes. And then last but not least, we have 2 over x plus 1, x minus 1. I'll write it in its factored form, so that way we can clearly see what's going to cancel and what isn't. It turns out that most things will cancel, right? So x plus 1s, see you later. X minus 1s, peace out. And that leaves us with just this lonely 2. So minus 2. And now we can start to clean things up. So I'm going to subtract x to both sides. And I'm going to also combine 1 minus 2. So that's going to give us 2x minus 3 is equal to, let's see, -1. And then we're going to add 3 to both sides, which gives us, I'm running out of space, sorry. I'm going to have to go up here, the rest of this. So this is going to be 2x, and then -1 plus 3 is 2. So equals 2. And then I divide by 2, you get x equals 1. And you break into the happy dance because this was a whole lot of work to do. And if you didn't do this at the beginning, this would be a false solution because we got an answer. We got x equals 1. So we're like, hey, that must be our answer. This must be a conditional situation for us because we got an answer. And in chapter 1, when we got an answer, that was the only answer. It wasn't like, oh, I had to go back and check to make sure that it was all legit. Over here, we do, because we have values that are going to force these denominators to be undefined. And those values specifically for this equation are -1 and +1. Well, we just said we're trying to convince ourselves that x is equal to 1. But over here, we say x cannot be equal to 1. So this right here is a contradiction in the fact that we said that this is our answer, but it's not in the domain. So this is a false solution, which means there is actually no, no solution to this problem. It looks like we did. It looks like we got an answer, but this is no solution. And the only real way to figure that out is to first figure out what's in the domain, solve the equation business as usual, and if you get a number that's on this list, you know that it's no solution. I wish that there's a slick way for me to tell you that you're going to be able to like look into the future to find it. There isn't. There's no way to tell until you get an answer and you cross-reference it with this list over here. Okay. So if this were me on a test, I would 100% give you a problem like this to make sure that you are actually doing this process. Since MyMathLab generates the problems, you give them like a general idea of like what question you want them to do, and then they randomize the numbers so that way it's not the same for every single student, but it's the same style of question. I can't guarantee that they'll do this. So know that they do exist, but I can't guarantee that you will see this again. You probably will see it on your journey of like doing the homework, but it may not be on the test form. All right, so let's do a couple more of these and then see where this takes us. All right, so quickly, I'm going to say this is my x such that x cannot be equal to, cannot be equal to 3 or -2, because again, I factor this in my head, and when I factor this in my head, I get 2 and -2, so 2 must be on that list as well, and 2 and 3 are -2 and +2 and +3 are on this list over here as well. And this should be -3, sorry. So there we go. So here's our list of things that x cannot be equal to. So again, -3 and -2 and +2 cannot be values for x. So when you factor these denominators, again, you have x plus 3, you have x minus 2, you have x minus 2, x plus 2. Again, I'm just factoring these denominators over here to figure out what my LCD is going to be. And you have x plus 3 and x plus 2. So this time our LCD is going to be a little bit more interesting. It's going to have 3 components to it. So LCD is going to be x plus 3, x minus 2, and x plus 2. So again, there's more to it than just the 2 elements that we had in the previous LCDs that we had. And again, we can see that because we have an x plus 3 here, we have an x minus 2 here, and then we have an x plus 2 over there. So it's all the different factors, and it's the product of all the different factors. So let's do some side work. So side work. So again, we have 4, and then this x squared plus x minus 6. And we know that if we take this LCD and we multiply it into this denominator, the x plus 3 and the x minus 2 is going to cancel, and you are going to be left with just the x plus 2. So again, if you multiply by the LCD, you're going to be left with 4. Obviously, this 4 is not going anywhere. And you're going to be left with the x plus 2. Okay? So this first fraction is going to turn into 4x plus 8, because of course you need to distribute the 4. All right? So again, the LCD, which is this guy, if you multiply this, and this is in the denominator, okay, this is in the denominator, the x plus 3s are going to cancel, the x minus 2s are going to cancel, you're left with the x plus 2. All right, so the next one we have 1 over x squared minus 4, multiplying it by the LCD. And this time, the x minus 2 is going to cancel, the x plus 2 is going to cancel, you are left with the x plus 3 this time. So we have this minus 1, parentheses, and then the x plus 3 is remaining. And when you distribute, you should have negative x minus 3. So that's what that becomes, is equal to, and last but not least, we have x squared plus 5x plus 6 multiplied by the LCD. And this time, when you multiply the LCD by what the denominator is, which is the x plus 3, x minus 2, x plus 2, the x minus 2 is not going to cancel. So this will be equal to the 2, which is obviously not going to cancel, and then the x minus 2. So x minus 2. And when you distribute, you get 2x minus 4. And at this stage of the game, we are straight back to chapter 1. Again, this was probably day 1. Right after we went over the syllabus, we started solving equations that look like this, so this shouldn't really scare anybody in the class. So again, if we want to carry this through and solve it, I'll probably kill a couple birds with one stone to do this. So 4x minus x is going to be 3x. Subtract 2x to both sides, you're left with just x. And 8 minus 3 is 5. And then you subtract 5 to both sides, you get negative 9, because you have a negative 4 here already. So negative 4 minus 5 is going to be negative 9. And that looks like it's a valid solution because it is not on my list up here. So this is good to go. Okay. All right. Let's see. Let's see. And I wouldn't worry too much about the graphing. This is not in the, I don't know why this is still here. I thought I hid these slides. So let's just do this last example here. And then that'll be it for this video. So x, let's do our domain first, x such that x cannot be equal to negative 3, x cannot be equal to positive 1. And what happens when you factor this? Yep, those are the same two factors you would get if you factored this denominator. So x plus 3, when you factor that, you get x plus 3. You have x minus 1. When you factor that, you get x minus 1. And then this one over here, this x squared plus 2x minus 3. When you factor that, you get x plus 3, x minus 1. So the product of the first two denominators. Now let's bang out the side work. So 2 over x plus 3, when you multiply it by the LCD, x plus 3, x minus 1. Boom, boom, those cancel, and you're left with 2x minus 2. So of course, you need to distribute the 2 into the x and the negative 1. So this is going to be 2x minus 2. And then let's do this 1 over x minus 1, multiplying it by the LCD, x plus 3. And the more you do these, the more you start to really see how they behave. You know that these will cancel and the other one is going to be left over. So that's going to be x plus 3, because when you distribute, actually, we can actually turn this into negative 1, and now we'll turn that into negative x and minus 3. So minus x minus 3, so we can distribute the negative, this negative right here, and this is equal to negative x squared minus 3x over x plus 3, x minus 3, and when you multiply that by the LCD, x plus 3, x minus 1, sorry, this should be minus 1, not minus 3, cancel, 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 and you are left with just whatever the numerator is, which is negative x squared minus 3x. So negative x squared minus 3x. And we're in a little bit of a pickle this time because we have this x squared term here, and there's no way that that x squared term is going to go away. So one of the things that I'm going to want you to really start to realize now is that anytime you have a quadratic, and we know we have a quadratic because we have an x squared term. If you have a quadratic, the only way that we know how to solve quadratics at this point in this class is to set it equal to 0 and factor. So we use the technique that we use at the end of chapter 5. So we are going to move all of these components to one side of the equation so that it's equal to 0, and then we'll use the 0 factor property to go ahead and solve. So I add x squared to both sides. I add 3x to both sides, and that's going to give us x squared, because again, you add x squared to both sides. You have 2x minus x, which is 1x. Added 3x is going to be 4x, and then this is negative 2 minus 3, which is negative 5, is equal to 0. And this is factorable, thank goodness, because again, that's the only way that we know how to solve this at this point. So this is going to be x plus 5 and x minus 1. Those are the two factors of this quadratic. And then we get two solutions this time. We get x is equal to negative 5, because remember, we set this equal to 0, set it equal to 0, and set it equal to 0. So we get x is equal to 5, and we get x is equal to positive 1. But this guy right here is on my list of things that x cannot be equal to. So it felt like we got two solutions here because we had a quadratic, but this is a false solution, and this x minus 5 is our only solution to this equation. So I hope that you found this video to be thorough. I hope that you found it helpful. I think some of the feedback that I got was that you guys sort of enjoy it because you can, pause it, review it. If you need some refresher, you can go back to it. So, I don't know how much you're actually enjoying it, but you like the fact that you can go back and review it if you need it. So thanks so much for your time and attention, and I will be posting the invitation for the Q&A session tomorrow, as well as Chapter 7 notes. Remember, review your exponent rules so that way you are prepared for what you're going to see tomorrow.